regarding the envy
Okay.
with
So
beta.
one was good.
So the two, I just want to double check. What would the value for XI and XJ be? Would XI be $10 and XJ would that be 25?
For question two,
Yes, for the question two.
well, remember what matters is how much you end up with. You just said xi equals 10, but that's not what they end up with.
Is it-
The second player ends up with 25 and the first player with 5. Okay, and, excuse me, we're talking about the second player's utility. So now you should think of xi as being the second player's payoff, which is 25. And you should think of xj as being the first player's payoff, which is 5. And you have to think now, okay, should I include alpha or beta? Well, the second player doesn't feel any envy because the other player isn't getting more. He does feel guilt because the other player is getting less.
Why is XI player one and XJ player two?
Did I say that? I didn't mean to say that. XI is player 2 in question 2.
Yes, because I was thinking I would be the first player. That's not the case?
No, I is you. I is the person. Okay, so maybe I need to show you this equation again. The reason xi is the person we're talking about here because I is a subscript of the utility function. Utility of player I is equal to player I's payoff minus whatever envy or guilt that it gets subtracted to off. So why is xi referring to player 2 now? It's because it's player 2's utility that you're trying to calculate.
Got you. Okay, sorry.
If I asked you to calculate player 1's utility, then xi would be player 1's payoff. Okay.
I see. Yes, it's from the point of view of the second player.
Good. I'm sure there's other people that are also getting confused about this. And I really do think they may be thinking of it too much as in like all I need to do is plug and chug these numbers. I don't have to think about what it means. It'll actually help you to think about what it means. This isn't all of these formulas and variables. They have a meaning that is actually not too hard to understand what the meaning is for each of these variables. UI is player I's utility. XI is player I's payoff. XJ is the other guy's payoff. Now, whether I equals the first player or I equals the second player just depends on the question that's being asked. If I ask you about player 2's utility, then XI refers to player 2. Who's
right? Because question 2 is specifically asking the second player's.
It is. Yeah.
Their Schmidt utility. Okay, that's.
Yeah.
Thank you for clarifying.
And question 3.
That's
question
where I
3
messed
is
up.
also about player 2's utility.
Okay, I'm sure if I understood that, I'd have gotten the right answers.
Yeah, and you can do it again. This is a homework that you can submit multiple times.
So I hate to ask this again, but number 2, you're looking at 25. Not, is it okay if I just say the formula like that I plugged in? Okay, so 25 minus 5, because that's 25 is player 2, 5 is player 1, but player 1 gave money to player 2. So 25 minus 5. Then beta, because player 2 feels guilt for not giving money. And then you would take that number that you get, which is 16, and you would subtract that from player 2's payoff, which is 25.
Yeah, I think this is. Yeah. I think you did it right.
So 25 minus 16, and I.
Did you put that in and it calculated it? Gave you the wrong? Said it was wrong?
Yeah. No. I was right. It was just when I was doing it yesterday, it was just really confusing. But I think it's because like I didn't understand the use of beta. I thought you were just putting it in the question. I didn't know that it had to deal with guilt or envy.
I put it in the question because in general, I think you would like to know what a player's alpha and beta are. Mm-hmm. And I guess I'm testing you a little bit to know which one do I need to use. Mm-hmm. I'm giving you alpha and beta, and it's up to you to figure out, wait, is this a problem with alpha or is this a problem where I need to use beta? and it depends on if it's guilt or envy. Just remember, alpha is envy, beta is guilt. I don't know if there's an easy mnemonic to remember that or something, but I mean, even if you didn't remember it, my slides about social preferences will tell you. But yeah, that's why I put it in questions 2 and 3. Does that make sense to everyone for questions 2 and 3?
Wait, can I ask another question about question 2 real quick? Where did the 16 come from?
Well, I guess because he took the difference between 25 and 5 and got 20. Would you agree with that?
Yeah.
And that's the difference in the payoffs. You have to multiply that by beta because that tells you how much guilt you feel. And 20 times 0.8 is 16.
Okay.
That's just the math there. 0.8 times 20.
Yeah. Mm-hmm. Then what do you do with the 20? Or no, never mind. I see now.
Yeah. So these they're called parameters. Alpha and beta are parameters that you use in the utility, the formula for utility, just so that you know how much should I be subtracting for envy? How much should I be subtracting for guilt? You have to just multiply beta 0.8 times the difference in payoffs, which is 20. That's where the 16 comes from. Did that answer your question?
Yeah.
Good. So actually, I think the hardest ones were questions 4 and 5. Maybe they were easy to guess the right answer, but maybe harder to figure out from scratch, start to finish.
Hey, before you touch on 4 and 5, for number 3, how do you know the payoff? Like, so if player 2 gives 10 back, are you calculating the number 30 or are you calculating 15 and 15?
So are you asking how will you know the player's payoff?
Yeah.
You just have to do some math there.
Okay.
You have to know what the trust game is, which I actually, even if you've never seen the trust game before, I think I'm explaining it to you in this question. And
and you made it pretty clear in the video on VCU Econ as well, but
yeah. So you want to know what their final payoffs are? Take the $25 and subtract 10, get 15 for the second player. Take the $5, add 10 to get 15 for the first player. So they both have 15. But the answer is math. You have to add and subtract to get those numbers. And you know, why didn't I just tell you, oh, then they end up with $15? I guess I just wanted you to do one more step of acknowledgement of what this is. It's a trust game and that you understand how a trust game works. That's part of the course. That's part of behavioral economics. So yeah, that's where that comes from, question 3. Can I go on to start talking about questions 4 and 5? Anybody else have? I think I'm sharing what the homework looks like, which is just question 1, 2, 3, 4, 5, and now I'm on 4 and 5. It's the same trust game where the second player has fair Schmidt utility with alpha equals 1, beta equals 0.8. That's the same as in so far. It's always been the case. The first player knows this fact. You should pay attention to that statement. The first player knows this fact. When in reality, you can't just look at somebody and know what their parameters are. But for the purposes of this question, we're going to say it's as if they can. It's as if they know the person they're playing is going to have an alpha equals 1 and a beta equals 0.8. Now I'm going to tell you what the first player's parameters are. The first player has a parameter of alpha equals 0, beta equals 0. If you recall, that is the same as being self-interested. So if you have fair Schmidt utility with alpha equals 0 and beta equals 0, that means you behave just like Homo economicus. Homo economicus is actually included as in the model of fair Schmidt utility. It's a special case, the case where alpha equals 0 and beta equals 0. So what would be the optimal amount of money for the first person to send to the second? Do not answer with the $sign, just the number. To answer this question, you have to think about what is the way the first player will get the highest utility they can. Well, they're Homo economicus, so that just means get the most money they can. you can set, what is the optimal amount of money to send? You can send as much as 10 and as little as 0. You could send anything in between. To answer this question, you should think about how will the second player respond? And perhaps you realize that by, I've primed you to think about that based on questions 2 and 3. You look at question 2 and 3, you can kind of see, well, man, what's player 2 going to do? And once you figured that out, is player 2 going to give a bunch of money back, give half the money back so that the playoffs are equal, or will player 2 keep all the money? You can compare the utility from question 2 and question 3 to answer that. I'll just tell you, if the utility is higher in question 2, that means the second player will keep all the money. If the utility is higher in question 3, that means the second player will spread the money back to the first player until they're even. Okay, so from between 2 and 3, you've resolved that. You should know, okay, the second player will either return the money so that we're equal or keep all the money. And that informs question 4, which is what's the best thing to do expecting the person to behave this way? And I guess I'll just tell you, and you can tell me if you agree, if the person is going to give the money back to you so that your payoffs are equal, don't you want to send as much as possible to that person? I think so, right? The answer would be 10. If the person's going to reward you with half of the total money, then you want the pie to be as big as possible, which means you send as much money as you can to the second player. However, if the second player is going to keep all the money for himself, then I don't think you want to send him anything because you know you're not going to get returned anything. So what I've just told you, I hope, is a really big hint. You have until 1:30 to do this. The real reason it's bad to make something due at the end of class is that people who haven't done it are just going to work on the thing instead of paying attention to class. And that was basically a typing error by my part, I think, or maybe I forgot when class began. But oh well, I'm not going to change it. I set the due date at 1:30. I hope you guys can do it. I either have already done it or you can do it quickly and not use all the class time thinking about this homework. And then that's part of the reason I'm helping you right now, right? Oh, by the way, look at question 5. Notice this. Please notice this. The second player's utility has changed in question 5. That's the only thing that's changed between 4 and 5. In question 5, the second player becomes a homo economicus. And the first player knows this fact. You may be confused by this fact, but wait a second. You're saying the first player has utility of alpha equals 1, beta equals 0.5. Does that mean the first player wants to send money to the second player even if they don't expect anything to come back? This is part of what I'm asking you about Fair-Schmidt utility. Would a person ever want to be, so self-sacrificing that they lose a bunch of their own money to make somebody else have a lot more than them? I'll just tell you now, the answer is no. Nobody would ever hurt themselves in a way that they become disadvantaged relative to somebody else, according to this utility function. That means you should be able to answer what happens in question 5. It doesn't matter what alpha or beta are. If I'm giving you money and that just causes there to be more inequality, I'm not going to do it. I'm only give you money if I think you'll return it and maybe we'll have an equal amount but higher level of more for each of us. That's when I will send you money. If I think you're not going to send me anything back, I'm not going to send you anything in the first place. It doesn't matter what my alpha or my beta are, because you never want to be disadvantaged. You never want to get less money than the other person. You can avoid it. I can't see myself in this. The little Thumbnails. Oh, here I am. Okay, nobody else has their camera on. I guess it's just me. Do you guys have any questions about this homework? I tried to give you some significant hints on how to do it. I want you to get a full credit for it. I want you to get 5 out of 5. It's really just like a reading response. It's equal in points.
I have a question.
Sure.
So Fairschmidt predicts that no one, or if you have a beta of at least 0.5, then you're going to give up until you're even, right?
Correct.
Okay, so is there any mathematical justification for people that just give up some portion but not enough to bring themselves to totally even?
Yes, very good. You need a more complicated, it's called a social preference
Okay.
theory. A more complicated theory of social preference may say that your payoff goes into my utility function. And in fact, generally, the more you earn, the happier I am, up until this point maybe where you start to earn more than me, and then I actually don't want you to earn too much more. But there could be some substitutability in there. Just like food and shelter are you want food, you want shelter, but at some point there is a substitutability between these two consumption goods. I've seen theories, I've used a theory that treats social preferences the same way. In other words, let's say I'm a dictator and I have $10. Maybe the reason I give $2 to you is because there's some indifference curve. There's some indifference curve where, you could think of 0 and 10 as being a line. I'd like to draw this if you don't mind. Just to answer Peter's question, I'm going to draw a picture. Sorry, Peter. Sorry, rest of class. Peter has asked a question which I'm interested in and I want to answer. Here is the axis for your payoff. Here's the axis for my payoff, right? So y-axis is your payoff, x-axis is my payoff. Let's get a different color here. This line here represents the amount of possible things I could do in a dictator game, right? This top here would be 0 for me, 10 for you, and this would be 10 for me, 0 for you. So actually the prediction of standard economics is that we should, I don't know what blue, is that we should all be sort of right here. This is 10 for me and 0 for you. And this up here would be 10. I will call this Y for you and me, M for me. That's very, very crude. It's like how you would explain it to like an 8-year-old. This is mine, this is yours. Okay, sorry. No, it's really a more academic subject than I'm making it sound. But here's my answer to Peter's question. If you go beyond this class, if you learn about other social preference models, let's say you want to get a PhD in economics and one of your fields you want to study is behavioral economics, go ahead and do that. That'd be cool. I would be happy to have you as another person who works on this kind of stuff. You'll likely learn about more complex models of, they're called social preferences, where, let me do some text here. I'm gonna do some text. Where, so like the utility function is of M for my payoff, Y for your payoff is equal to some, M raised to some power, theta times Y raised to some power, maybe 1 minus theta, something like that is, for example. Okay, and then what do the indifference curves of this sort of utility function have? Guys, I'm not going to test you over this, okay? So don't expect this complicated of a utility function to appear on a quiz or an exam. I just want to give it to people who maybe they're thinking of going to grad school in economics and like, hey, if I want to do this, what kind of stuff will I be learning? Well, you actually have some freedom for what you'll be learning, but let me still talk about this equation here that I've written. This is a way to describe the substitutability between my payoff and yours. I want you to have more payoff. This is a little incomplete, I have to say. Even what I've done is inaccurate because I don't have any I don't have any thing that changes once you get a higher payoff than me. But indifference curves for this might look something like, how about in green? Something what? Something like this, right? And that means the optimal thing, the thing that maximizes my utility, is to keep, let's say that's 8. I keep $8 for myself, and I give $2 to you, right? So if you add this curvature, to the utility function, then you get these interior solutions where maybe I'm not keeping all of the money, or I'm not giving you half the money. I'm doing something in between, but you need some curvature to the utility function. Does that answer your question, Peter? Are you there? Uh-oh. This whole time I thought I was talking to him.
Yes, I'm here. Sorry, I'm just helping someone out. But yeah, that does answer my question.
Yeah, okay. Cool. And the relevant thing is I'm not testing you over that in this class. You won't need to know any other models of social preferences except the one model of social preferences I'm asking you to learn is by Ernst Fehr, Klaus Schmidt. It's now called inequity aversion, even though at the time it was called a theory of cooperation, competition, and reciprocity. Okay. And let me stop sharing. Okay, do you guys have any other questions about the homework? That's 2 at 1:30. Wait a second, but class goes to 1:45. So by those last 15 minutes of class, I'm gonna have your undivided attention because your homework will all have been turned in, right? Okay. This is definitely why you do not make homework due in the middle of a class. That was a mistake on my part. I'm gonna lecture as if I would a little bit. I might even do an exercise, and people who want to participate can. People who don't want to don't have to. But I'll make it worth a little bit of extra credit, just like I did last time. And actually, let me say a little bit more about what happened last time before we go on. And that is, we played a game called the Beauty Contest game. Is that a dumb name for this game? Beauty Contest game. And I have a video about it. So I really recommend those of you, at least who didn't play this game, to go on vcuecon.com and watch my video about the Beauty Contest game, where I describe it in a much more detail. Where's the name come from? Excellent question, Michael. You know, it comes from one of the patron saints of liberal economists, and that's John Maynard Keynes, the English economist from the 1920s, 1930s, I don't know, was he still alive and doing work in the 40s? I think so. Here's the idea that Keynes had. He thought about a situation where there's a newspaper game, and the newspaper game says, I'm going to publish the pictures of 50 people's faces. You see 50 faces, some men, some women, or maybe they're all women, I don't know, but just a bunch of faces. And your job is to select the faces that are the most beautiful, the people who you think would win this beauty contest. And how is the winner determined? So there's two contests. There's the contest to see who's the most beautiful, and there's this prediction contest, the contest to see who can predict the best, who will be the most beautiful, who will be chosen as the most beautiful. But so here's the thing. The winner, so the people selected to be the most beautiful aren't necessarily the most quote unquote beautiful. They're going to be determined by the answers to the people who are playing this prediction game. There's a whole level of it where it's removed. What does this mean? Well, it really means everyone isn't just choosing who they think is the most beautiful. They are choosing the ones who they think other people will guess are the most beautiful. That's like a one step of realization here. There's another step, which is that actually you're not trying to guess who you think other people actually think is the most beautiful. That's not actually what you're doing. You are trying to guess who you think that other people will guess that other people will think is the most beautiful, right? Because if everyone's playing this prediction game, then nobody's being asked, all right, just tell me the truth who you think is the most beautiful. Nobody's doing that. Everybody who's participating in this game is trying to win the game of prediction. And so they're all trying to think of who would other people think that other people think. There's another layer that other people think, dot, 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 forever. In fact, what Keynes realized is this is an infinite regression of consideration of other people's beliefs. I'm speculating about what other people are speculating about, etc., backwards in time. And so he thought about this game and said, there are some weird things that can happen in this game, which is that everyone kind of, whatever the sort of standard perceptions of beauty are that we as a nation think are the most important, that's what tends to win these games, and it might not actually be accurate. Maybe that if people were all telling the truth, they would select something else. Okay, that's where the name comes from, beauty contest game. How is it used? Why did Keynes actually talk about this? It's because he thought of it as a metaphor for the stock markets and other markets, other equity markets. What happens when you are an active trader in a market and you see the price of something and you're speculating about the future price? You're thinking, I could buy this equity now, and if the price goes up, I'm going to make some money. What are you thinking about? Are you thinking about whether the actual true fundamental value of the equity will increase? Not really. You're thinking about whether other people will think that the value of this equity increases. Wouldn't you agree? Because let's say you buy a stock now, if in a year from now the stock has gone up in value by $10 per share, you make a ton of money. It doesn't matter if the actual value of the company went up or down. All that matters was that there were enough people out there whose perceptions of the stock improved that they were willing to pay more for the stock, and therefore the value went up, the market value went up, and therefore you made money. So Keynes had this idea that a lot of markets and equity markets had the same principles of the beauty contest game were being applied to these market games. And so he kind of stopped there. Behavioral economists took this game and ran with it. It started with a German woman named Rosemary Nagel. She did some experiments about how do people play this beauty contest game so she was very clever. I think she had some co-authors, but there was this idea that I could create a game where if everyone were doing what the equilibrium predicts, it would give you one really stark prediction, which was 0. Everyone should just choose 0. They should think, oh, this equity or whatever it is I'm guessing about, the value of it will collapse all the way to 0, and 0 is the true value of this that I should predict. As opposed to what really happens, which is that people are imperfect about their ability to speculate about what others will do. Nobody's perfect. I remember the very first time I played a beauty contest game. I was a senior in college. This was like 2001, a long time ago. I had to play this game, and I was asked, here's the game. The game is choose a number between 0 and 1,000, and the winner is the person who guesses 1/2 of the median of all the guesses. How do you win this game? How is one determined as the champion of this game? It's the person who is most accurate in predicting what other people will do. And baked into this game is that you're not just predicting what other people will do randomly, picking between 0 and 1,000. You're predicting how other people would predict that other people would play. And actually, you're predicting how other people would predict that other people would predict how they would play in this game. It's just like the beauty contest game, isn't it? This idea that Keynes wrote about in the 1930s, which was that sometimes markets can suffer from this alternate reality that comes from, I'm always just thinking about what the perceptions of other people are. I don't even care what the true reality is. I only care about the perceptions. Well, this is a game that really tests that. That says the winner is the person who is accurate in their perceptions of what other people will do, even knowing the fact that everyone has the same incentives. Everyone is trying to outguess everyone else by one step. You know, I said between 0 and 1,000. If you think that the average is going to be 500, the median is going to be 500, and then what should you do? You should guess 250, because 250 would be the 1/2 of the median, or 500. But this is like not considering at all the strategy of the game. If you guess 250, you're saying, I have no idea what other people are going to choose. They'll probably just choose randomly. Who knows what to do in this game? So that would be 500. I'm going to pick half of that, and that's 250. This is the first step of the beauty contest game. This sort of zero strategy. Well, oh gosh, let me take that back. It's called level 1. There's a name for it. Okay, so I'll put it in the chat. Sorry. I have slides about this. This is the next behavioral model I'm asking you to learn. The first one was the Fair-Schmidt model, called inequity aversion. The second model is going to be called the cognitive hierarchy model, or cognitive hierarchy theory. It's by Colin Kammerer and maybe a couple co-authors. But it starts with this idea that there are levels of strategic sophistication that people use when they're thinking about a game like this. And if you did exactly one level of strategic thought, you would say, well, I want to choose half of whatever the median is, and everyone else is going to just choose randomly. So if they choose randomly, the median will be 500. Half of that will be 250. So a level 1 player in this game, somebody who has this one level of strategic thought, would guess 250. What about a level 2 player? A level 2 player, by definition, according to this model, is somebody who thinks one step ahead of the level 1 player. So a level 2 player thinks, well, other people, not me, but other people are going to guess 250, because that's half of 500, which is the midway between 0 and 1,000. So a level 2 player thinks other people are like level 1 players. They're going to say 250. What should I do? I should say 125. So the level 2 player thinks about this game and says, I'm going to choose 125. Well, the model doesn't stop there. I'm getting a little bit ahead of myself. I want to talk a little bit more generally about game theory before I get to this model. Okay, let's read what Michael said. If somebody's a level 1 player, wouldn't you assume they'd continue the regression? I assume by regression you mean thinking about that and then thinking about that and thinking about that. The answer is no. By definition, a level 1 player believes that other people are just going to play randomly. Other people are not going to, so level 1 is one step higher than level 0. A level 0 player truly does not think about the game at all. They were out to lunch. I was explaining the game and they weren't paying attention, so they don't know what they're doing. They just pick a random number. That's called level 0. I should tell you that. That's a real thing, level 0. A level 0 player has exactly 0 strategic thought about the game. Okay? So Michael's question, why doesn't a level 1 player start to realize, wait a second, you know, if I choose 250, isn't that what everyone's going to do? So maybe I should choose 125. Here's my answer to you, Michael. I have a perfect answer for this. Maybe you don't think it's perfect. Here's my answer. If a level 1 player thought, wait a second, isn't everyone going to choose 250? Because that's what I'm going to choose. If they have that thought, they immediately become a level 2 player. By definition, a level 2 player, this is called a cognitive hierarchy. You know what a hierarchy is? This is H-E-I-R-A-R-C-H-Y. I think that's spelled. I'm not even sure. But it's about levels, and there's a bottom level, a top, and each one kind of goes up. You can think of a hierarchy as a system where there's systematic ordering of people and of cognition. That's why it's called the cognitive hierarchy. So the levels of cognition are ordered and structured in this way that a level 1 player, by definition, never has the thought that you just suggested. A level 1 player, by definition, doesn't think, wait a second, if I choose 250, isn't that what everyone else is going to pick? Everyone's going to pick 250. I should pick 125. If you have that thought, then you become a level 2 player. Now, if you then have the thought, wait a second, isn't everyone going to choose 125? Because I was just about to say 125 and thinking that that's what I'm going to pick. Of course, it's 125. But if everyone thinks that, I should pick half of that. I should pick 62.5. If you have this thought in your brain, you automatically become a level 3 player. So does that answer your question or your comment? You gave this comment. Wouldn't you assume they just continue the aggression? No. If they continue the aggression, they become a different, like think of it as a floor of a building. Like the bottom floor is level 0. People who are just, you know, blindfolded, running around randomly, monkeys on typewriters, just random stuff. That's the level 0 floor. If you like look around and see all these people with, you know, you believe this is how people act, like monkeys on typewriters, you're like, okay, I got to choose. I got to respond to that. That makes you level 1. You're on the first floor. Or the second, I don't know. Never mind. I don't know if the floor analogy is so good. But if you're aware of that and thinking, wait a second, I got to respond to those types of people, the level 1 people, you become level 2. And it goes on forever. You could have level 3, level 4, level 5. Okay, so that is the cognitive hierarchy model. And there's actually kind of a lot of evidence for it. There's a great TED talk that Colin Cameron gave. I hope I have time to show it to you sometime. Or maybe I'll ask you to watch it on your own. It's not that long. But what they do is, you may not know this about Colin. I'll pretend like I'm a first name basis with him. He's actually most passionate about neuroscience, about neuroeconomics. And that is the science of studying the different parts of the brain and how they're connected, and how we can actually infer something about brain activity in terms of cognition. And when you present someone with a problem that they have to solve, or something they have to choose, you know, what's appropriate to do here? Do I care about this or this? What do I think about other people? And this is like empathy. Whether you have a theory of mind, you think about, wait a second, this other person has their own mind and they're thinking about it just the way I am. There's certain parts of your brain that are activated. And if you strap they're called MRIs. So you guys know what an MRI is. An MRI is a really big machine. You have to lay there and be flat. And so they don't do that. What they have is a functional MRI. It's just a lot smaller, and you can put it on someone while they're still pretty much mobile and interacting and making decisions. So if you use these functional MRIs, you can get a scan of people's brains. You can learn about what portions, what regions of the brains are activating. How do they know that? Just by more neural activity causes more blood, and I don't even know, but they can scan that. They can tell. I think it's magnetic, right? That's what the M stands for, magnetic. So here's the brilliant thing Colin Kammerer and his colleagues have done is scanned people while they were making the decision of what to do in the beauty contest game. Isn't that a cool? You ask somebody, hey, pick a number between 0 and 1,000, and we're going to ask everyone to pick a number between 0 and 1,000. The winner is whoever gets half the median. I have to say this, actually, the canonical, you know this word, it's mean like the usual, the thing that normally is done is not half the median of between 0 and 1,000. It's 2/3 the average between 0 and 100. I don't know why. I like median better than average. I like half better than 2/3. And I like 1,000 better than 100. But anyways, I didn't come up with this. The most commonly tested version of this experiment is to ask people to come as close as they can to 2/3 the average of the guesses between 0 and 100. And what they, so here's what, I'm probably not going to show you the TED Talk because I'm just telling you right now everything that he would have told you had you watched the TED Talk, is that there is a consistent pattern of brain activity among people who you might say are level 1 and also among people who you might say are level 2. And it's really hard, it's subtle to tell, but they found a lot of evidence for it about which regions, and it does have to do with theory of mind and strategic empathy, these other things that psychologists maybe care about more. It's related to economics. There's a huge interaction between, I'll tell you his name again. Probably asked what this person's name is. Colin Kammerer. I think he was at Caltech for a while, but I think he left to go to one of the other University of California schools because he wanted to. Maybe for a lab. He's always, what he cares about is having a nice big lab to do a lot of his own research in. Anyways, here's the really clever thing, I think. They told people to play this game against a human being, and they also told people to play this game, or a similar game, not exactly this game, but this game against a human being, and also play this game against a robot. Why would you do that? Why would you have the same person play against a person and then also play against a robot? Here's why. They were studying the brain scans of the people in both cases and trying to decide, what's the difference? What did you do differently when you played against a human as opposed to playing against a robot? Well, first of all, what should you do differently? Of course, when you're playing a human, you should really think about, what is that other human likely to do? Based on my estimation of what human beings are like and what they do. Whereas when you're playing against a robot, you don't need to think about that, especially if somebody tells you how the robot is going to play. Maybe you have to think about math, you have to think about optimization, but you don't have to think about empathy, about what human beings are like, because you're not playing against a human, you're playing against a robot. Okay, so what they did is got all this data, the brain scans of people as they're playing against humans and robots, and compared the two to look at where was the biggest difference, what parts of the brain are most activated in this case, but not in this case. And they found just enormous amount of evidence that corroborates this hypothesis that says there are levels of strategic sophistication that are types that are sort of built into the types of person, that some people kind of think about humans and robots the same way, and they choose the level 1 level often in games like this. They're pretty common level 1 thinkers in the sense that they didn't go to the next step and think about, well, wait a second, I'm playing against somebody who's strategically thinking about me the way I'm thinking about them. And it's because the part of they're not using the part of their brain that has that theory of mind and theory of empathy. Whereas the level 2 players or level 3 or higher, they really are. They have that capacity in their brain to think, when I'm playing this game, I've got to think about you, and I've got to treat you with some humanity, not just like as a thing I'm playing against, but as another person who will have the same strategic thoughts that I have. So it's fascinating. I recommend you watching it, or I'll link it to you or something. He also does studies of chimpanzees and compares how humans and chimps behave in strategic situations. In some ways, chimps are better. Chimps are more strategic than humans. Can you believe that?
Wow.
There's
Very much so.
There's proof. And in fact, there are theories. The theory is that when chimpanzees were evolving, they were more social than humans, and they were more interested in basically outsmarting their peers to get the social status. Like there was like first, second, third, fourth, fifth. Like if you're a chimpanzee in a social group of chimps, you know exactly what your order is in your social status, and you're always thinking strategically about how to improve that. And because more parts of their brain are focused on that, they're actually better at this certain strategic games of predicting what the other person will do and reacting to it. And when I say person, I actually mean chimp. The chimps are better at reacting to what the other chimps will do and forming some kind of equilibrium, approaching equilibrium. Whereas humans are actually out of equilibrium in these predictable ways. That's what behavioral economics is about, saying how are humans different than what theory would predict? And the answer is they don't behave the same way. Gosh, it's already 1:28. Do we have time to do one more test of your brain power and your strategic thinking? You guys want to do an exercise? What do you think?
Sure. Yes.
Okay, so here's what I'll have you play. It's called the Centipede game, and I'll show it. Share a screen with you on it right now. I think. Oh no, here's the beauty contest game. But I also have a picture of the Centipede game. Slideshow from current slide. Can you see this game? It's called the Centipede game because there are two players, and when you draw the picture of the game, it's supposed to look like a centipede. I don't know if you agree with that or not. But what do you see here? You see points. These numbers here, 4, 1, 2, 8, 16, 4, 8, 13, 8, 32. Those are payoffs listed for player 1 on top and player 2 on bottom. So, and each of these circles here represents the decision that the players make. So if player 1 starts the game here, and they can either choose to continue the game, in which case we follow this arrow, or they can stop the game, in which we follow this arrow. If player 1 stops the game ends, and these are the payoffs. So player 1 gets 4, player 2 gets 1. Everyone see that? If player 1 continues, now we have a circle where player 2 has the decision. Player 2 could stop the game and get 2 for player 1, 8 for player 2, or continue the game, in which case we go to this circle. Now player 1 has a chance to continue or stop the game. If at any point the game stops, that's it. And the payoffs are determined by whatever these numbers are at the arrow where you stop. If you continue all the way to the end, you'll end up here getting a huge payoff of 256 for player 1 and 64 for player 2. So we can get 120 points on our overall grade. I think you mean OUR. Yes. If you do this game, you could get 256. Here's the issue though. At every step of the way, the player would rather stop than let it continue if they thought the game was about to stop. That's why it's called a game of preemption. To preempt something is to act before something else is going to happen. I take some preventative or precautionary action to preempt. Oh, you're gonna attack me. I'm going to attack you before you attack me. That's preemption, and that's what's built into the Centipede game. That at every level, look at player 1. Player 1 would rather stop here than here because 4 is better than 2. Player 1 to stop here, they would rather stop here than here because 16 is better than 8. Player 1 would rather stop here because 64 is better than 32. You see that at each step, and the same is true for player 2. If player 2 stops here, they get 8, which is better than letting it continue. If the next person's going to stop, they only get 4. Here, player 2, if they stop here, they get 32, whereas if they continue and the next player stops, they only get 16. So at each step, you're sort of risking having your payoff get cut in half. By choosing continue, you risk having your payoff get cut in half. But if the other player continues, then you'll do better. You'll do actually much better. Guys, if you're assigned player 2, don't be a bad person. Okay, so are we ready to play this? Who would like to play? Let's get ready to play the centipede game. I gotta stop sharing. I'm gonna continue sharing because I want you to be able to see it. Oh gosh, how can I have both at the same time? How can I have you see the centipede game and record your points? I actually think maybe I should record your points on a separate piece of paper so that I can just share the centipede game. I'd rather share the centipede game so that you can see it. You know what I mean? That's the most important thing for you to know while we're playing. Okay. So I'm going to take the first 2 people who said they want to play. I'm going to just use a notebook here to write your names down, and I'll write how many points you get. Oh, by the way, you do not get to play this game unless you unmute yourself and actually talk. If we're doing it all by chat, I don't think it's the same. I think I want you to like take time and give an answer, and then the other person hears your answer and hears your decision, and then they make a decision, and then they hear it, and we need this sort of audio confirmation. Sorry. Let me look at who was the first person to say they would play. Kevin said sure. Does that mean sure I will play? What does sure mean? Is that what you meant? Remember, you have to talk here. If people won't talk, I'm just not going to have play this game.
I think I'm going to let a couple other people play this time. I feel like I've been playing a lot.
Okay.
This is a 2-person game.
Extra credit points? Okay, but we maybe have time to let anybody who wants to play. Okay, Ibrahim said yes, and Alexander. So I'll do Ibrahim, you'll be first player, and Alexandria, you'll be the second. You understand? Are you guys here?
Yes.
Alexandria?
Yes, I'm here.
Okay, so here's how this game was work. I will say player 1, and that's Ibrahim, and you have to say either continue or stop. Then I will say player 2, and then that will be Alexandria. Then you have to say either continue or stop if the game continues. But I want you to wait for me each time so that there isn't this sort of lack of understanding. Okay? And when the game stops, that's what will be the payoffs that are determined. You understand the game?
Yes. Got it.
So Ibrahim, actually I'll say your names. I won't say player 1, player 2. I'll say Ibrahim. Would you like to continue or stop?
Continue.
Okay, Alexandria, continue or stop?
Continue.
Okay, now we're at the third. We're at the third circle. Ibrahim, continue or stop?
Continue.
Okay, we're at the 4th. Alexandria.
Continue.
Okay, we're at the 5th. Ibrahim.
Continue.
We're at the 6th. Alexandria.
Continue.
Oh, you made it to the end? That's 256 points for Ibrahim and 64 for Alexandria. Wait, so Alexandria, you didn't want 128 points by stopping?
I did, but I mean, I don't know, like I'll take 64.
But you could have had you could have had 128. What if that like gives you a guaranteed A in this class, but now you don't because of that? That's very generous of you.
Thank you.
I saw how it was coming, but I
Okay.
just said continue.
I'm curious as to what other people will do. Let's talk about Sierra and Nick. You're the next 2 to say. Go. Sierra and Nick, are you there?
I'm here.
Sierra? Hello, Sierra? We're going to skip you if you're not here. James, you here? Hello.
Sierra
Yes,
said
I'm here. Sorry, I'm here.
Wait, Sierra, you're there now?
Sierra said 1 second.
Well, let's just play with Nick and James. Because we don't have a second. We got to go. All right, Nick and James. I guess, Nick, you went for, you said I'll play first, so you'll be first player, and James, you'll be second player. Is that okay?
Mm-hmm.
Okay, Nick, we're at the first circle. What would you like to do? Continue or stop?
Continue.
James, we're at the second circle.
Continue.
All right, Nick, we're at the third.
Continue.
James, we're at the fourth.
Continue.
Nick, fifth.
Stop.
Okay, stop. That is
It's a good choice.
64 points for Nick and 16 points for James. Is that right? Okay. So Nick, you got 64, the same amount Alexandria got actually, but Ibrahim is crushing all of you with 256. Michael, you said you wanted to play?
Yeah, I do. Can you hear me?
Yes. And the next person after Michael is Sarah. She said can play next round. Zachary, you want to play?
Yeah.
Okay, I guess it'll be Michael and Zachary. Michael, you go. You go first. You could stop right now and get 4 points.
Continue.
Oh,
I want to continue.
Okay, Michael continues. Zachary.
Continue.
Okay, we're at the third circle. Michael.
Continue.
Okay, we're at the fourth circle. Continue or stop. Zach.
Continue.
Zachary, what'd you say? Continue. Okay, we're at the fifth circle. Michael, continue or stop.
Continue.
Oh, we're at the sixth, the last circle. Zachary, would you like to continue or stop?
Stop.
Oh, Zachary, you get 128 points. Man, you guys are racking up the points. 32 for Michael. Can you see my scoreboard? I don't know if you can. Okay. Who else said they would be interested in playing this game? Nobody else. Okay. Well, we don't have to keep doing it.
I'll play. I'll play around if Sierra wants to play.
We also got Brody.
Yeah, I want to play.
I'll take Kevin. Kevin, you'll be first. Brody, you'll be second. I mean, so far somebody got 256. Everyone's gotten at least 16 points. Okay, who said first? I think Kevin, you were first. Brody, you were second. So Kevin, you're the first player. Do you want to continue or stop?
I'll continue.
Brody.
Continue.
Kevin, you're at the third. Continue or stop?
I'll stop it.
You're going to stop there?
Yeah.
I was going to keep going, bro.
Kevin, you got 16 points.
Bro, I was going to go to the end. Fake.
You can call me someone with trust issues.
Sierra, are you ready?
Yes, I am.
Is anyone gonna go with Sierra?
Well,
I'll go
Can I
again.
go again? Oh.
No, you only get one chance.
I'll play.
Who said I'll play? Who said that?
Fergus will play.
Fergus. Okay, Sierra, you'll be player one, and Fergus, you'll be second. Okay.
Wait, who's second? Sorry.
His name is Fergus.
Does he know? It's crazy. We went to community college together.
Wait, does he know how to play? I thought he did.
Yeah, I know how to play.
Did you just wait? How come Fergus is muted?
I just go back and forth muting myself when I'm not talking.
I see. Okay, but you will need to talk to play this game.
Yeah, I got it.
Okay, Sierra, you are the first player. You're at the first circle. You can continue or stop. Which would you like to do?
Continue.
All right, we're at the second circle. Fergus.
I'll continue.
All right, we're at the third circle. Sierra.
Continue.
All right, we're at the fourth circle. Fergus.
I'll continue.
All right, we're at the fifth circle. Sierra.
Continue.
Oh, we're at the sixth. There's the last circle. Fergus, would you like to continue or stop?
I'm gonna stop.
Oh, he's gonna stop. He's gonna take 128 points. Sierra, you get 32. Wow. So far, Ibrahim's got 256. Zachary and Fergus both got 128. What else? Alexandria and Nick both got 64. People are doing very well in this game. Thought we were cool. You were cool. You got pretty far. Michael and Sierra both got 32. Kevin and James got 16. Sorry, Brody, you're in last place. You only got 4. How much time do we have? Oh, it's 1:43. Okay, you're a weak man. Did anybody else want to play? I think that's it. I think we satisfied everybody who was interested. I'm giving you free extra credit points for playing this game, and nobody else wants to. Yeah, Alexandria or Ibrahim, you basically get a free A in this class because you're going to get so many extra credit points just from this one game. You don't even have to take the final because you're going to get a free. Almost.
I hope you're serious.
It's not quite true. No, that's not quite true. You can't share the points. Well, wait a second. Let's talk about what should happen in this game. If everybody is self-interested and everybody thinks that everybody else is self-interested, think about the beauty contest game. Everybody is like predicting that everybody else will be. Michael says we stop at 1. Why? Why would you stop in the first one, Michael? Anyway, by the way, you're correct. You're correct. Because you think the other person will stop. Why should you think that the second player will stop at the second circle? Why should you think that the second person will stop? Because we're all self-interested and they assume we'll stop. Basically, yes, I agree. You know what? The right way to think about this, or not the right way, the game theoretical way to think about this. I'm running out of time, so we'll talk about it next class. It's called backward induction. If you've ever studied game theory, I really hope you've heard this term before. Backward induction. What it means is, I look at the end of the game and I calculate what somebody would do if we reached the end of the game, and then I use that to figure out what I should do in the round immediately before that. Figure out what's the best thing to do in the round before that, and I use that to figure out what I should do in the round immediately before that. That's why I'm using induction, but backwards. So let's use backwards induction in the centipede game. Player 2, if they ever get to the very last circle, player 2 should stop, because they get 128 points instead of 64. So player 2 should stop according to, self-interest. They should stop. Alexandria chose to continue anyway. I'm not sure why she gave up 64 of her points so that Ibrahim could get an extra 220 something. That was very, very generous of Alexandria. I'm wondering if she really understood the consequences of this game, or maybe she's just that generous of a person. I don't know. But the prediction of of backwards induction is that you would stop here if you got to this last circle. Well, think about the second to last circle. Should you continue or stop? If you know that the game is going to end at that last circle, you're player 1, you could either get 64 by stopping or only 32 by continuing. So you should stop in the second to last circle. This is what backwards induction does. Says I should stop here, I should stop here. Well, what about the third to last circle? If I continue, I know the game is just going to end because of backwards induction. And if I'm player 2, I'll only get 16 if I allow it to continue. I'll get 32 by choosing to stop. So I should stop here at the third to last circle. Well, by the same argument, I should stop in the fourth to last circle, because player 1, if they stop, will get 16 here. This is now the third circle. In the third circle, if I stop, I'll get 16. If I continue, because of backwards induction, I know I'll only get 8. But this keeps going all the way back. And here you should stop because because 8 is better than 4. You should stop here. Well, it means in the very first game. And of course, nobody stopped in the very first game, in the first round, circle. This is an example of a stark difference between game theory, the game theoretic prediction of backwards induction, and what really happened when we played this game. Everybody made it to at least the third circle. Kevin ended the game in the third circle, but everyone else made it to either, everyone else made it to the fifth circle, actually, I think. Yeah, because there's no 8s and 32s on here. So everyone else made it a lot farther. So backwards induction is wrong. Backwards induction just didn't do a good job of predicting how people actually play this game. Here's what I like to do. I'll give a reading assignment and a reading response that's very closely related to this. It's called, it's by Colin Kammerer, of course, and it's about behavioral game theory. And it talks about these specific ways where game theory makes bad predictions. where the way humans really play the game is different than how game theory predicts they would play it. So, you know, just I'll put the assignment up, and you can write a little thing about that. It'll be due Monday. But other than that, that's it. We don't have a quiz on Monday. We'll push a quiz back till later. We'll decide when we want that in the next quiz. You guys have any questions? Those of you who have participated, thank you for participating in the Centipede game. Ibrahim, you did unbelievably well. I don't know how. Did you guys have something worked out? Did you guys have like a DMs back and forth?
I was thinking of using the guilt, but and I think kind of worked.
Yeah, I'm still shocked that she let it go all the way to 256 for you.
No, thank you so much, Alexandra. So kind.
But everyone did pretty well. Actually, everyone did pretty well except for maybe Brody. Sorry, Brody. But you didn't lose anything by playing. This was an opportunity to gain a lot of points. I want to let you guys go. Have a good weekend. Kevin became the very thing he swore. Oh, that's a good comment, Brody. That's a good comment. I like that.
When is the reading response due? Did you say next Tuesday or next Thursday or Wednesday?
I'd like it to be due Monday.
I'm sorry. Okay. All right.
Is that okay?
Yeah, of course.
You have 5 days to do it. I'll post about it soon so you can see. Am I still recording?